What's going on, guys? We have a simple exercise 8.10, and this is taken from the book of Fundamentals of Engineering Electromagnetics. Yeah, it is the name of the book. Also, that book, the author is David K. Chang, if you wanna find the book, okay? So, this is the chapter 8, transmission lines, and 8, 8.10, okay? This is the exercise number. We are going to try to solve this problem by using Smith chart, okay? So, I think we can start. The input impedance of an open-circuited 75 ohm lossless transmission line is capacitive reactance of 90 ohm. Use the Smith chart to determine the length of the line in terms of wavelength. Okay, so let me try to draw. Okay, the circuit first. Okay, let's say this is our generator. Yeah, and it says I'm drawing with the mouse pad, touchpad. Okay, so it may look quite straight, as you can see. So input impedance of an open circuited 75 lossless reactance of 90 ohm. Okay, so we know the input impedance. It is given. It is capacitive reactance of 90 ohm. So I will explain this. Also, we know the RO. This is the 75. It is RO. Okay, it is equal to 75. We may need this later. Also, we need this definitely. Then, okay, it is saying the input impedance is capacitive reactance of 90 ohm. Also, RO, we know this. And yeah, also we know this open circuits. Okay, so it is open circuit. Now, it is given, let's say this Z input, it is here. This is given. Okay, also the open circuit, we know the endpoint. So it is asking what? This length. So what is this length? We are going to try to find this length. Okay, it is asking where. Use the Smith chart to determine the length of the line in terms of wavelength. Okay, the Smith chart is already given the values in wavelength. So this is L, by the way. Zi open circuit, and we need to find this length. Where is it? So I will use this Smith chart, Figma design. Okay. What do we have? Open circuit. First of all, if we are using impedance, so the open circuit is here, right? Let me write. Open circuit is this, exactly this point for impedance, and this, it is short circuit. So we have this point, it's saying open circuited. So we have this point. Also, what we have, Zi impedance, input impedance. Okay, so it is capacitive reactance of 90 ohm. So let me tell you, Zi, it is exactly, the real part is 0 because it is only capacitive reactance. It has imaginary part only, no real value. Real value is 0, and capacitive, since it is capacitive, it is minus j 90. Okay, we also need to find this point on this Smith chart. Okay, so but we cannot find the value of 90 in the Smith charts. For that, we are dividing by RO. We need to divide 90 by RO, which is 75. Okay, let me divide it. I'm not using paper, so I can use the calculator. 90 divided by 75 is 1.2. Okay, so normalized. We have found the normalized value of zi, so it is normalized, so you can, yeah, you can indicate it with this line at the top. Normalized zi is equal to minus j 90 divided by 75, it is 1.2. Okay, so now we can find this value on the Smith chart. Where is it? Here. Minus j 1.2. Okay, the minus values at the bottom of the chart, right? Minus j 1.2. The center is 1.2. Okay, the real value is 0, this point. Okay, so, and the real value is following the outer circle and it is going to 0. Okay, 0. Yeah, we have our 2 points, this one and this one, this one and this one. Okay, we have our 2 points and we need to find this distance. I think z normalized, open circuit. Yeah, open circuit is here. Yeah, now we just need to find this value, this distance in lambda. Okay, how can we do that? Let me take an arrow here. Now you need this to be centered. Let's go deeper. Yeah, now yeah, now I need to rotate this. Okay, this is the rotation point, so I need to carry this one here now. Okay, one point two. Okay, now we need the wavelength value here. Okay, 0 point, exactly we can say 0 0.36, 0 0.36. Also, we already know this value, but okay, so this one we already know it is 0.25. I'm taking the outer values. This is 0.25 and it is, as you can see, it's increasing, so up to 0 point. So this is the distance, okay, between 2 points. This is the length here. So we just need to subtract this 0 point. We need to subtract this value from this value, so we are coming from here to here, so this is the bigger value. We need to subtract this 0.25 here from this value. Let's take this here, 0.25. If you can subtract, I can see it is 0.511, 0.11, 0.11 lambda. Okay, so this is our final result. Also, the answer is already given since this is an exercise, 0.11. Okay, so this wasn't a complete tutorial of the Figma or Smith chart. This was, I directly solved the problem, but if you want or need, I can give the details of the Smith chart, but I just wanted to solve this problem because it's hard to find the exercise from the book. So I just wanted to solve. I assumed he already knew the basics of the Smith chart and Figma. Maybe you don't know the Figma. I can also explain the Figma if you want. Okay. So this was the answer, and I am planning to solve one or two more problems.